Hello, everyone. We're just going to take a couple of moments here for everyone to join, and then we'll get started. Hello, everyone. Thank you for joining us today. I'm Nick Gorinsky from the Foursquare marketing team, and I'm pleased to be joined by Foursquare's distinguished engineer, Vikram Gandetti. Today, Vikram is going to talk us through the how and why Foursquare has identified and seized the opportunity to build a first of its kind geospatial knowledge graph that will reinvent how our customers derive insights and location intelligence today. Thank you for joining us today, Vikram. Take it away.
Thanks, Nick, for the introduction. Hello, everyone. Today, I'm going to talk about Foursquare Graph and how it makes it easier for businesses to derive value from geospatial data. I'll start with a brief history of Foursquare and the products we offer, identify some of the challenges in handling geospatial data, and explain with examples how Foursquare Graph addresses this problem. So let's get started. Let me start with a bit with the origins of Foursquare. If you have used mobile apps in the 2010s, you must be familiar with Foursquare. It is the social networking app that popularized the notion of check-ins. Unlike the social networking apps of today, where you're focused on the screen, it was one of those apps which incentivized people to go out, discover new places, and meet new people. In enabling these experiences, what Foursquare developed is a very nuanced understanding of the places in the real world and people's movements around those places. In the late 2010s, Foursquare pivoted to enterprise and transformed into the invisible location layer of the internet. We are trusted by some of the big brands such as Uber, Snap, Nextdoor, Redfin. Anytime you open your app and it tells you where you are or there are location-centric experiences, most likely you're using Foursquare products. So our product line consists of data products like Places and mobile SDKs and APIs, which we offer to mobile developers, and software services related to the advertising domain like attribution, audiences, and proximity. We also have a visualization tool, which enables analysis of large-scale geospatial datasets. Our entire product portfolio is built on top of two foundational primitives, Places and Moments. Now let's talk a bit about the opportunities and challenges with geospatial data and why it is gaining a lot of momentum lately. So what is geospatial data? Geospatial data is any data tied to a location or a geographical segment of the earth. It could be a place, a building, weather, traffic information, population data. All these are fit under the broad umbrella of geospatial data. Why is it gaining a lot of momentum these days? Is like with the proliferation of mobile devices and IoT devices and geolocation technologies, there is a massive amount of data being tagged with location information. Now, when we think about location, why is it useful? When we think about location data, we think about mobile apps. It's whether it is like getting your delivery ETA or taking an Uber ride. But there is a broader class of problems where location data plays an important role, or geospatial data plays an important role. For instance, and these are very critical business investment decisions. For instance, you're planning, Starbucks is planning to put up a new store somewhere. They need to understand the demographics of the neighborhood, what are the places within that neighborhood where people are spending time, or Walmart and Costco want to understand the competitive insights. How many people are visiting Walmart are also going to Costco? What is that? How do you understand that? Like, and based on that, like, understand the reasons for why they are going. Or other use cases are you want to optimize your ad spend to target people at the locations or at people who are likely to act on your ad. So all these different use cases leverage location data or could benefit massively from geospatial data. But today, only 26%, according to a survey done by Forrester, only 26% of the data strategy leaders are leveraging location data to its fullest potential. About 95%, but when you ask a lot of execs, they either want to invest in geospatial data or say that it is important to their results. So when this is so important, why let's talk about what are the challenges in using this geospatial data in practice. Like, why are companies shying away from using geospatial data? So I'll walk through two examples. Let's say the typical site selection example. We want to put up a new brick and mortar store, and it's important. It's an important decision because you want to yield a return on investment. If you make a bad decision, that will have a significant impact on your operating expenses. You may lose market share, and you may also have a low revenue. But to make an informed decision about site selection, what are the kinds of information that you need? You need neighborhoods, like what are the neighborhoods people are spending time in for the kind of stores that you want to put. What kind of foot traffic do specific locations in those neighborhoods attract? What are the similar categories of POIs within that neighborhood? What are the demographics of the people visiting these locations within those neighborhoods? You need to have all these data sets to be able to make a more informed decisions. You may also want to attach it to some sales data or transactions data, or you want to identify similar stores that and look at their revenue, foot traffic patterns to make these decisions. Similarly, for lead generation is like about where do you want to stock up your products, or in which stores do you want to put certain product. And that can depend on a lot of factors. It can be based on consumption patterns, seasonality to the consumption patterns based on temporal events like concerts going on, or is it a football season, or and historically how the sales have trended at different times of the year. So the challenge with gleaning insights from this data is that like you have to have a lot of data sets, and you need to build not only join a lot of data sets, but also keep historical information, historical snapshots of these data sets so that you can identify and study patterns. So the pain points with geospatial data, if I were to summarize, is that like you need a lot of multiple different geospatial data sets. You want to join to be able to infer insights, as I've demonstrated in that example. And all of these data sets are not available in a single location. You have to source them from different vendors. You have to clean them. Merging and maintaining these data sets requires specialized tools like PostGIS and specialized skill sets. Now, the other thing is like if you have to maintain all this historical data to look at to study patterns, it requires it increases costs. So companies have to put up this upfront investment cost, upfront investment to derive any value from geospatial data, even though the value they derive may be much higher. So this is what is slowing down the adoption of geospatial technology in businesses. So what we saw was an opportunity to solve this problem and reduce the time to value from geospatial data. So what we built is a geospatial knowledge graph, which brings together various different assets and connects them together so that customers can derive value from that instantaneously. So what is a knowledge graph? And knowledge graphs are not new. Knowledge graph is a semantic network of real-world entities represented in a graph-like structure. The structure enables us to reason about it normally as you would in real life. You understand the relationships between the entities better. And some of the successful examples of knowledge graphs in the technology land are Facebook's social graph and LinkedIn's economic graph, right? What we have done that is slightly different is that all of these graphs ultimately organized all their data around users. So personal graph was a big thing in Foursquare, in Facebook, right? So you wanted to understand information about like all different possible information about a user, direct or indirect, and really understand people. What we are trying to do is apply the same techniques, but use spatial units, like whether it is POIs, H3 cells, neighborhoods, as units around which you can organize this information. What it will allow us to do is like answer more nuanced questions by way of traversing these relationships. So you can have a Yelp rating for a place, which is 4 or something, which doesn't really tell you anything. Or you can ask this question, hey, where are people working in this neighborhood going to lunch, right? Like typically going to lunch. And that's a more nuanced insight. Or if somebody wants to do some basic analysis around like what is the coverage of grocery stores, you want to understand like what are the top grocery stores in this area and which are the zip codes it is serving. So those are the kinds of questions it makes, the knowledge graph makes it easier to answer. So the knowledge graph itself is not new. So why did Foursquare choose to build it, or why do we think we are uniquely positioned to build the Foursquare graph? It boiled down to, I mean, there are a lot of parallels to other infrastructure platforms for us in terms of what we have done. Places and movements are like the storage and compute of the geospatial world. And we first started with focusing on these primitives, like why having any question that is related to the geospatial domain. Even when things like when there is a disaster going on, the people's movements are a good signal around like where there is impact because of a disaster, right? So places and movements are so foundational that we needed to first make sure that like we are differentiated in this space. So that was our first step towards building the geospatial knowledge graph. And if we didn't have this primitives, the graph would not make sense. So I'll take a bit to explain why we are differentiated and how we approach these primitives differently than most of the other companies which are in the same domain. So places. So if you look at the architecture of places in any company, it follows a simple, it follows the same pattern. You typically aggregate places from different sources, websites, trusted data providers, and all that. And then you try to cluster them to identify which sources are all talking about the same place. So you build that place record and apply your own secret sauce to determine the final record. Now you will have, in this final step, you will have some ML algorithms which are trained off of a sample of some human labeled data so that you're doing it in the right way. We did that, we used to do that. But what we did over the last year was we pivoted in terms of how we are approaching places. The problem with the places is that it's always changing. So you need consistent human verification. And if you go back to the roots of Foursquare, Foursquare built an entire places database based on human verification, right? Like humans, the only way Foursquare built places data in the past was humans provided inputs, and we had a crowdsourcing network. And based on that, we built a very robust representation of places in the real world. Now, what we did was we brought together the best of the digital world and validations at scale with real humans. And Foursquare is a unique company in that aspect that like we have a network of 50K super users who constantly curate our data and make it robust. And then anytime someone uses our APIs, for instance, you're sending a location information through a messaging app where they use Foursquare apps, Foursquare APIs. And when you select the place, we get feedback that like, hey, this geocode is mapped to this place or this place is real. So that's how we are able to do this consistent human verification at scale. And over the last year, we have improved our tools to be able to augment these human capital with machine learning models. And this is how we are able to break the digital bubble. Otherwise, like if you are in the places market, you understand every provider feeds off of every other provider, and there is the same reinforcement echo chamber that happens. And it's really difficult to say which one is better over the other. So instead, we are relying on the human network to make our places data more robust. So then movement data. this is another primitive that we have. And Foursquare has built this very nuanced understanding of GPS signals. Anyone who's worked with GPS signals would know that GPS signals are inherently error prone, right? Like you go to a restaurant and you open up your phone and you see a GPS signal, you're actually on the other side. The GPS signal shows that you're on the other side of the road. What most companies do is like or the typical pattern is like for identifying movements, you take a place, you draw a polygon around it or a geofence around it and try to see how where these stop locations of the users are pointing to. But Foursquare's approach is slightly different. That first thing has a lot of error because GPS signals rarely fall around a radius. And what Foursquare has done is like when people check in, we get ground truth data, we capture a lot of signals, and we use information about the place categories, like what are the categories you are likely to visit at this time of the day. And based on that, we are able to map, based on that, we are able to accurately snap to the right places. And snapping to the right place is important, especially when you have strip malls or crowded malls, or multi-storied malls or airports. Foursquare does very well, is proven to be accurate in those, even in those dense areas, in mapping to the right stores because of our training methodology and all that. And we've made significant investments over the last year to keep up with some of the changes in how changes in the mobile technologies, like whether it is imprecise location or only foreground location. And we've been able to keep up with those changes in that industry to still keep our data accurate. Now, I think there is a symbiotic relationship between places and movements, and that's the reason we continuously use the feedback loop to improve both of these products together. And that is the reason you cannot easily snap places from one provider and movements from the other provider and just snap them together. So then we brought in places and we have places and movements. We built a bunch of products on. But what we noticed was that like we still had users not deriving value from the geospatial data sooner, right? Like it was still taking a lot of time for our customers to derive value. And when we looked deeper into some of those use cases, like the ones I talked about earlier, it was that like they were trying to join with other data sources to derive more insights. And sometimes the data is their own data, like transactions, or sometimes it's more open data sources like buildings and roads from OSM or boundaries or census and all that. As it turned out, internally, we were doing the same thing for our own products. For instance, for places, when the way we determine accurate geocodes is by looking at roads information, is by factoring in roads and buildings information to snap the geocode to the right location. So the other challenges that we had to solve was how do you, like we have these different data sets and they are not easily joinable, right? Like because they are spatial, you either have points, polygons and all that. And that's where our usage of H3 was important to this whole strategy. So we indexed all our data sets by H3. Anything that has a location can be mapped to H3. But there are a lot of indirect data sets like transactions, data sets like events, which can only be associated back to places. So having, again, this is one of the reasons I say places and movements are the storage and compute of the geospatial world, because having a robust places data set and being able to constantly improve and take feedback from these various sources is an important aspect for us. And so you can associate concerts where they are going on to places. And the other entity that we had is like we had a bunch of user information aggregated from our own apps or second party apps. And we have interesting information about those users that we are now able to build it into our own graph. So organizing all these data sets, we built a common backbone within our company. We had teams contributing into this graph, publishing newer data sets, but also consuming from this graph to make those products, their own products better. And what it allowed us to do, and So this is one of the things I would say is like the biggest scam of 2010s or the last decade was big data, and all data is equally important. We have about thousands or several thousands of data sets that we publish into data lake, but not all data is equally important. We were able to identify some 50 data sets which were reusable, which are useful for keeping track of which were useful for keeping track for consumption or building new products. And that is what we baked into the graph. What it allowed us to do was reveal hidden insights, that making our analyst's life easier in terms of revealing hidden insights from this data quickly, improve our own existing products, and make sure we are building all our future products on a strong privacy foundation. And what I mean by that, I'm going to walk through some examples. So this is a visual of busiest intersections in LA at different times of the day. As you can see, the red dots are the busiest intersections at different parts, and you can see them changing as the animation goes through different hours of the day. Now, we don't have traffic data. The way we are able to infer this data is defining an intersection. An intersection is defined as any place where two roads intersect. So we use the roads data set to identify the intersections. We identified places, places that are busy and closer to the intersection to mark an intersection as busy. So that means we identified, so we had to join the intersection, and we found all the places within a 50-meter radius of that intersection and aggregated the visits to those places to determine a busy intersection. Now, why is this data important, right? Like, if you are a ride-hail company, the traffic data might not give you any nuanced insight. But if you know, hey, here are the places, here are the places closest to these intersections where people are spending this time at this time of the day, it could be a very strong signal for demand prediction. If you have a digital billboard and you want to optimize how much you're charging based on the time of the day, this is a good insight. When you know which time of the day you're likely to get more eyeballs, right? So this is one example. And this, I think, doing the same insight before without the knowledge graph would have been easily several months of effort. And this we were able to put together within a couple of hours. And one other thing that is notable over here is like we are using our hex tiles technology, where these red color, the color of the cells is determined automatically based on the values we are computing around the busyness of that particular intersection. So the hex cell corresponding to that intersection has a score assigned, and based on that, like we're animating. So now you're able to assign values to a H3 cell that is derived from 4 other data sets and visualize this at scale. And you could use the same values in your machine learning algorithms, which can open up new possibilities. So what good is a knowledge graph if we can't improve our own products, right? And here's an example is one very simple example of what we could do to improve our own products using the knowledge graph, right? So this is what we did was like we identified all buildings in a particular area. We defined a mall as something that has more than 10 POIs. And then we identified the top 50 malls in the city, right? And we were able to get to those ones in LA. For improving our own product, how does this improve our own products? One is it is using, because we are using the buildings, if all the POIs fall on the same building, and some of them don't have the right address, we know we can infer from the adjacent POIs that address, one of them is either wrong or we need to fix that address, and that might be important. Then the second thing is like when you're taking an Uber or a Lyft, a drop-off point is very important. If we know all these POIs are within the building, and the building likely has 2 or 3 drop-off points depending on how many roads it spans, it's easier for us to understand, like consolidate the drop-off points of POIs around that particular building using these heuristics. The other thing is, other most straightforward thing is a lot of times people want places tied to buildings and understand like what the parent POI relationships, where is this resident on. It's easier for us to infer these relationships at scale now by way of joining all these different data sets. Then finally, one of the things that always comes up when we are talking about location is privacy. And I also talked about us having user data within our knowledge graph. But the way we are building this knowledge graph is like all the queries will begin with the location as the central unit. What I mean by that is like even the examples I showed, they're all based on aggregate movement patterns rather than individual movement patterns. Like you can answer interesting questions like, hey, what are the zip codes from which people are coming? What is the demographic of this demographic of the people visiting the store, rather than tying it to a single individual. So this helps us, even if you take a very sensitive use case like advertising, we want to pivot from, hey, find me all the people who fit this criteria of being in this age group and are outdoor enthusiasts. We want to pivot those questions to what are the places where I'm likely to find these kinds of people. And that we can do through aggregate movement patterns without compromising on individual privacy. So to sum it all up, like why we think this is exciting for us and why our customers should be excited as well is we're solving the problem of connecting various geospatial assets easily to reveal hidden insights. Second, internally, by way of creating a common backbone for all our key assets, we are accelerating feature development and creation of new products. And then it demonstrates our commitment to privacy by way of making spatial units the center of our graph. So with that, I'll move on to Q&A.
Thank you, Vikram. We had some questions coming in throughout the presentation, so I'd love to get your thoughts on them. The first coming in is graph technology something that Foursquare invented, and are our competitors using graph technology?
I think, so graph technology itself is not new, and neither is graph thinking. What we have used, I think graph is, what we have tried to do differently is that like when you think of graphs, you always think about individual information or social graphs and other things. By making location a central aspect and by using spatial units like H3 or places or neighborhoods as the spatial units around which information is organized, we are able to, that particular aspect is something we believe at least is innovative in this space.
Great. We have another question. How can enterprises benefit from geospatial data, particularly in a privacy-first fashion?
I think, as I covered, right, like one of the things we have done by way of putting this in this spatial, by way of using spatial units and organizing our information around that, what we've been able to do is understand aggregate patterns and use that to find audiences at places as opposed to individually targeting the people. So when we understand behaviors of people in the aggregate and the places they visit, especially in a world where privacy is becoming more and more sensitive, or like the regulations of privacy around becoming more stringent, we see this as an opportunity to pivot the advertising avenues to be more location focused rather than individual focused.
Here's another question coming in that I really love. What are some of the engineering challenges you face while building Graph?
Yeah, I mean, I think the first of the things is that like, what are, like, I think, as I said, covered earlier in the talk, like you have a data lake which has about thousands of data sets. And one of the challenges we faced is like, we did not have a common backbone. So there were no notions of data contracts or anything of that sort. The graph forced us to identify these assets, define very clear, come up with clear schemas and contracts for these data, and then be able to join all of those. Then we had to go and look at some of the infrastructure options that we had in terms of modeling the graph and making sure it meets, we can derive these insights quickly, and is also compatible with the rest of our products in terms of our usage of H3 and all that. So those were some of the key challenges we had to move forward on.
Thank you, Vikram. That's all we have time for questions. On the next slide there, we've got some up and coming webinars that we're really excited to share with you. We have the Foursquare and the National Retail Federation discussing the evolution of the in-store journey on June 6th at 1 p.m. Eastern Time. And Foursquare's very own senior data scientist, Ali Rossi, will explore the 5 steps to geospatial analysis with our very own Foursquare studio on June 15th at 1 p.m. Eastern Standard Time. The links are dropped into the chat here, so if you want easy, quick access, grab them right now. And Vikram, I'd like to thank you again for joining us. It was great to hear everything about the graph and sharing about Foursquare's pioneering geospatial graph technology. On that note, thank you so much, everyone, for joining us today, and we'll see you next time.